Hey, Andrew.
Hey, Miss Sparks.
How are you?
I'm good. How about you? Miss Wynn told us that we had to join some point during the year. I don't need help with math. I was just joining because she said we needed to at one point during the year.
Oh, okay. So I can tell her you've done it. You can check
Yeah.
that off your list.
Yeah, I already did all my math homework for today. I was just doing this so I didn't get a zero on that at the end of the year.
Well, there you go. So basically, what you're telling me is you could just run Math Lab for me today.
Uh, I mean, I guess depends on how much you're saying.
Since you've already done all your math homework, I could just chill. Guest
Yeah.
speaker Andrew Norman for Math Lab today.
Well, someone's joining, so I'll go.
Okay. All right. Well, thanks for checking in. I'll tell Miss Wynn that you did.
All right, see ya.
All right. Take care. Hey, Garrett.
Name is Sparks.
How are you?
Good.
Good.
I was needing some help with the worksheets 4 and 5.
Okay, let's do it. I think I have them pulled up. Let me just make sure. Let's start with 4.
Okay.
All right. How far did you get in class yesterday?
8.
Number 8?
Yeah.
All right. Do you have questions before that?
A recap would be nice.
Okay. All right. Will do. All right. Let me pick a good color that'll show up. Sometimes that's really difficult graphing these, They don't like to show up. All right, let me do this. And I'm sorry if the graph is a little kind of ugly. I try, honestly. Okay, so a quadratic is going to be that U shape, right? Like that. And the equation can be written f of x equals x squared. Or you can write it y equals x squared. I don't care. I don't think she does either. And the domain is going to be any x that's possible. Okay? And all x's are possible because if you're running your pencil, let me do this. If you're running it along the y-axis or the x-axis, my apologies, you can see that basically because those rays on either end of the quadratic are going to continue on forever and ever and ever and keep getting wider and wider and wider and wider, that means all x's would be a possibility. Okay?
Okay.
Does that make sense to you?
Yes.
Okay. So you can write the domain. Did she say that she had a particular way that she wanted you guys to write it?
I just wrote negative infinity, infinity.
Okay. Sometimes I do that fancy all real numbers. So let me just do negative infinity to infinity. I hope you can tell that's a negative. Now, with regard to the range, oops, sorry about that. With regard to the range, it's going to go this way. So if I were running my pencil up that way, I would notice that my y's don't start till I hit the origin. There's nothing that goes on that bottom part of the y-axis.
So it's 0 to infinity?
Yes, sir. So that's that one. Absolute value is kind of similar in the fact that kind of has a similar shape. One's a U, one's a V. But the equation is f of x equals the absolute value of x. And once again, all x's are a possibility because if I were to run my pencil along the x-axis, all the x's would be possible because as those two rays, each end of those rays of the graph are going to continue on into infinity and get wider and wider and wider, thereby making all of the x's a possibility. Whereas the range, though, it doesn't start until, bam, it starts right there. So we've got 0 to infinity.
I think I understand 1 through 5.
Okay. You feel good about those then?
Yeah.
Okay. All right. Thank you for letting me know. All right. So for this one, for this transformation, we already know that the shape is going to be a V, like the absolute value. Oops, I didn't mean to do that. I'm trying to make my graph lines black so that my graphs show up a little better. But my transformation is going to be, if it's inside the parentheses, I'm going to be shifted what? Do you remember?
3 right.
Yep, shift right 3. And then outside the parentheses.
And then up 5.
Up 5.
Okay, I understand that now.
Okay, so let's just draw that. Shift right. Oh, God. It's not going to be great, I don't think. 1, 2, 3. 1, 2, 3, 4, 5. These little thingies are very teeny tiny. So I hope you bear with me on my graphs. It's kind of hard even for you guys, I know, on those. Okay, so let's talk about the domain and the range. The domain, those rays are still going to be extending and getting wider and wider and wider into infinity. So actually, all x's are still a possibility. Does that make sense?
Yes, but the range starts at 5.
Yes, that's it. That's it exactly. Awesome. I should be putting parentheses around that. I'm sorry. Okay, so on this next one, it's a quadratic. And my transformation is going to be shifted right 7. And it's going to be flipped across the x-axis because of the negative right there. Okay?
That makes sense.
All right. So if it's shifting right 7, I'm going to go over, and once again, it's probably not going to be real accurate because these graphs are teeny tiny and hard for an elderly woman to see. But for the domain, those rays are going to extend on forever and ever and ever and get wider and wider and wider. So the domain is going to stay the same in the fact that it will be negative infinity to infinity, but my range will actually be negative infinity to 0. Because if I'm looking at that y-axis, if I go up, it actually stops right there. So it starts negative and goes to 0 and then stops. Does that make sense?
Yes.
Okay. All right. So we've got the square root.
Wait, I have a question.
Yes.
Aren't we skipping 12 and 13?
Yes.
Okay, I'll just make sure.
Okay. And do you do you need help on the rest of these, or did you want to skip ahead?
I need help on the rest of these.
Okay. All right. So the square root, we're going to be shifted left 1. So it's still going to remain the same shape. So left 1 and then down 1. And once again, kind of an ugly So the transformation is left 1, down 1. So let's talk about the domain. That's all x's, okay? So all the x's, what x's are a possibility?
-1 to infinity.
-1 to infinity. Good job. You don't even need me. You're a genius. All right, now let's talk about the range. Where does it start?
Same thing.
That's right. Good job. You're doing great, Garrett. Okay. Now, this one we got 3 transformations going on. So, let's see. The transformation, you're going to shift left or right 4. Which way?
Left.
Left 4. Good job. Am I going to go up or down 3?
Down.
And then that 2, because it's greater than 1, is going to stretch this quadratic and make it move up much quicker, much skinny. It's going to be closer to that y-axis, right?
Okay.
So we're going to go left 4. 1, 2, 3, 4. Down 3. And then it's actually instead. Okay.
Your audio cut off.
Oh, it did? Are we good? Can you?
You said left 4, down 3, and then you cut off.
Can you hear me now?
Yeah.
Okay. That's weird. Sorry about that.
Fine.
Okay, so left 4, down 3, and then closer to the y-axis by a multiple of 2.
Okay.
Or stretched. So the domain is going to stay the same because once again, those 2 rays are going to extend and get wider and wider and wider. Correct?
Yeah.
And what's going to happen to our range?
I don't know.
If I was going to take my pen and run it along that y-axis, where would it start?
I don't know.
-3.
Okay. I don't really understand the stretching thing though.
The stretching, like this part, this multiple.
Yeah.
This right here. Okay. All right. So when there is and I think Miss Wynn actually posted a note on Google Classroom because I know I borrowed it from mine, that when there is a number outside, so let's say randomly it looks like this. Even if it was absolute value, x plus 2 minus 3, or if it's f of x equals 4, and then it's a quadratic. This number right here, outside the absolute value or outside the parentheses, outside the square root symbol, would make it skinnier. So it stretches it up. Or if it was an absolute value, the absolute value is going to be skinnier. So this stretches it or moves it closer to the y-axis. If that number is less than 1, so let's say it's 1/2 or 1/4, it would actually, I'm going to borrow this graph for just a minute. Let's just pretend this 2 was a 1/2, okay? It would make it fatter. So instead of being your regular quadratic, it would actually look like this. So it's kind of like it's being pulled toward the x-axis. But if it's like 4 or greater, then it's skinnier and it's being pulled toward the y. Does that make sense?
Yeah.
A little bit better?
Yeah.
So let's look at let's give a general rule for it so that you can apply that general rule. Let me get all this erased. And like I say, she put an image. Have you seen the image that she put up on Google Classroom?
The last page?
Yes, sir.
Yeah, I did see that one.
A general rule is f of x equals a, and then you've got your x minus h, and that can be squared, cubed, the square root, or whatever it is. You know, that's just a general form, plus k. When a is greater than 1, it stretches toward the y-axis. So it would get skinnier. Okay, if you will. Terrible drawing. Oops, didn't mean to erase that part. My computer locked up on me.
It's fine.
I'm going to have to reload this. Ugh. Okay. When a is greater than 1, it stretches toward the y-axis or gets closer to y. When a is less than 1, it compresses or squishes. Now it's not writing again. Compresses toward x-axis. Does that make sense?
Yes.
Does that help a little bit?
Yeah, it does.
Okay. So this number in front of either the parentheses, the square root, the absolute value, that letter A or whatever the number is, it's going to tell you whether it's going to stretch or compress. And it's going to either, when it's stretching, it's getting closer to the Y. Or best thing to remember is it's getting closer to the Y. And every time I use my eraser, it locks my computer up. I'm trying. Okay, so look at number 10 while I try to get my computer to cooperate. Is that going to get closer to the X or closer to the Y?
X.
Good job. Okay, number 11. Is that going to get closer to the Y or closer to the X?
Y.
Good job. There you go. Okay, and for number 10, it's going to get closer to the x-axis because that 1/2 tells us it's going to do that. Okay, what are your other transformations?
It's going to go left 4, down 3.
Perfect. And my computer locked up again. I'm so sorry.
It's okay.
Wondering if it's going to open. Well, I could probably walk through some of the rest with you. I just won't be able to write it down. I can talk through it with you, but it's not opening up. Does it help when I write it down, though?
Yeah.
Okay. I just don't know what to do. Why won't you open? Oh, wait. Praise the Lord. Please, Lord Jesus, help Garrett and I. Are you a junior?
Yeah.
Man, I can't believe that. Did you come here in 7th or 8th grade?
First grade.
Oh, 1st grade. You've been here that long?
Yeah.
Oh, I guess I just remember you from middle school, obviously, because that's when I start, that's all I teach is middle school and high school. So I can't believe how time has flown. All right. So number 10, the transformation is going to get closer to X. Shift. Well, my writing, left 4, down 3. No judgment about how ugly my little cubic's going to be, okay?
Okay.
Okay, left 4, down 3. That's going to be the turning point. And so it's going to be fatter. And the normal cubic kind of runs through the origin and looks like that. So this is going to be a little fatter. Okay?
Okay.
Just a little. Because it's going to rise and fall half as quickly. But your domain and range really don't change because both of these are going to continue on in the same direction forever and ever and ever. And eventually all X's and Y's are going to be a possibility. So the domain and range don't really change on this. It just is that there was a shifting in the graph. Does that make sense?
Yeah.
Okay. Okay, so this quadratic here. This one, the quadratic is going to be closer to Y. Oops. Right? Because of the 2.
Yeah.
And then shifted left 4.
And then up 6.
Up 6. Good job. And then, so left 4, up 6, and it's going to be skinnier. But once again, those rays are going to continue forever and ever and ever. So my domain is still going to remain negative infinity to infinity because those rays will get wider and wider and wider. But the range, however, is going to start at 6 and go on into infinity. Okay?
Okay.
All right. Now, I got to blow this up a little bit to be able to read these graphs. Can you still see them okay?
Mm-hmm.
All right. So what we're going to look for to determine this this graph is we're looking for that major turning point. Okay? And that's going to determine our equation. Does that make sense?
Mm-hmm.
Okay, so where do you think this is making, instead of at the origin, where is this kind of making its major turn?
4.
Yes. On the what? Y-axis? Is it making any adjustments on the, Lord Jesus, please help me to think. The x-axis.
Y-axis.
Yeah, the y-axis. I'm sorry. Is it making, you see it making any adjustments? Not really. It's not doing anything. It didn't shift left or right is what I'm asking. And what shape is this? What kind of, is this, what is this, a cubic, a quadratic, an absolute value? What is it?
Cubic.
Yes. So you would write down x cubed plus 4, right?
Yeah.
Because it's just shifted up. It made no adjustments along the x. It just shifted up on the y. So the domain is what?
Domain is 4.
The domain is all, every x, there would be a possibility, right? Because the rays on either end of this,
Infinity?
the behavior of this would get wider and wider into infinity.
Is it negative infinity?
Yes. So negative infinity to infinity, because all x's are a possibility.
Oh, I was thinking about the y-axis.
Yes. But even on this, the y's are going to continue because there is a y here, right?
Mm-hmm.
And a y here and a y here. So even though you have our major turning point is different right here, even though that's different, all y's are still a possibility, aren't they?
Mm-hmm.
So it's still going to be negative infinity to infinity, because what you're thinking about is this is going along the y-axis. So what, and this is the x-axis. The domain is the x-axis. So would every x be a possibility, and would every y be a possibility if these rays continue on into infinity? Right? Does that make sense?
Yeah.
Okay. All right. This next one for the absolute value. How is this one a little different? Is it going like every other absolute value?
It went left 3,
Right?
down 4.
Exactly. Anything else special about this one?
It's wider,
Or
is it thinner? Or no,
it
flipped.
could look a little wider, but
Whatever the x-axis.
yes, it's flipped.
So is it f of x equals negative parentheses? Oh,
Well,
you already wrote
it's
it down.
absolute. It's the absolute value. It's those straight lines.
You already wrote it down, but I wasn't looking at the screen.
Oh, okay. I'm sorry. Well, you could have told me. I would have believed you.
I looked up and I was like, oh.
Oh, okay. It's okay. Did you have what I have?
I was going to say, at least say that the negative is going to be in front of it all because that's what made it flip.
Yay! Good. Good job. All right. Let's talk about the domain and range. So the domain, that's dealing with the x's. What do you think about that?
Would it be -4 to negative infinity?
Actually, all x's are a possibility because if you think about it, the x's are the ones that run this way. So this is going to continue on and on and on. And this is going to continue on and on and on forever and ever and ever and get wider and wider and wider. So every x would be a possibility. It's just, does that make sense?
Mm-hmm.
Okay. So your domain are the x's. And so it's going to be forever and ever and ever going on and on. However, the y, not so much. The y, it goes this way. So the y, this y way up here, that's not a possibility, is it?
No.
This y here isn't a possibility. It's only from here down. So it would be negative, infinity to -4. Because all of these, the y only goes to there. But the x's go on forever and ever and ever. Does that make sense?
Yeah.
Are you seeing that a little bit better? I know domain and range can be so confusing. And I know for a long time it really was for me too. And then the video that I think I had somebody do something very similar to me that was like the video. And I don't know if Miss Wynn assigned the same one, but it was the guy that kind of runs his pencil along the x-axis and the y-axis. Was that the one y'all watched?
The video for today?
Yes, sir.
I haven't watched it yet.
Oh, okay. Well, he does that, and somebody did that for me a long, long time ago because it is something that I definitely struggled with. I don't know, for some reason I couldn't visualize it, and I don't know why, but that really helped me. So I sure hope that helps you because I know it really can be a little confusing. All right, this one on the square root. I'm not going to write it this time, Garrett. I want you to tell me, I don't want to mess you up, like I did that time and I'd already written it. So f of x. So tell me what's happening. The major point moved from 0, 0. Where did it go?
Up 5, right 2.
Up 5, right 2. So how would I write that?
Hold on. About the square root of?
Yep.
So square root of x minus 5. No, x. No, hold on. X minus 2.
Yes, sir.
Plus 5.
Yes, sir. That's it. Exactly. And I made my square root didn't look too good. So I'm going to fix it because it looked like it was trying to include that 5. Perfect. You did great. Okay, now let's talk about the domain. All x's are not a possibility in this one. Where does it start? If I'm running my pencil along here.
It starts at 2.
Good job. And goes to?
Infinity.
Good job. All right. So this one, it's a little easier to see because our x's don't start till there, All right. Now our y's, where does it start?
5.
And goes to?
Infinity.
Good job. Whoops. Oh, Oh my. So sorry about that. Okay. Now we're going to just write the transformations. At least I hope we are. It just vanished. Okay. So a quadratic. You want to talk to me? What's this? Do you want me to do the first one and then you do the rest, or how do you want to do this?
So I was trying to do it myself.
Okay.
F of x equals x minus 2 plus minus 3.
And this needs to be in parentheses and squared.
Yeah.
Okay, cool. Good job.
That's it?
Yes.
Oh, okay.
So it's x minus 2 in parentheses squared minus 3. And that's it. So the absolute value, this one says it's closer to the y-axis. So you know you're going to have that multiplier out front. Is it going to be greater than 1 if it's closer to the y-axis or less than 1?
Greater.
Good job. So you can pick any number. What number do you want to pick?
2.
Okay. An absolute value. And now what's going to go inside the absolute value?
X plus 5
Good job.
minus 7.
Good job. Awesome. That's it. Okay.
I think I can do the rest of these myself.
Okay.
Can we move on to worksheet 5?
I'm sorry?
Can we move on to worksheet number 5?
Sure. Basically, 1 through 5 are exactly what we did in class, and you said you had those down.
Do I have to copy them back down? Or should we just skip this, let me do it later? Since it's just a copy of the front, the other one.
Yeah, it's just to make sure. I know that a lot of this is repetitive, but it's just to make sure you have it. Do you know what I mean?
Mm-hmm.
Okay. All right, so let's talk about that for this first graph on number 6. What's the transformation?
Up 1.
Yep. So the domain is going to be negative infinity to infinity. And the range is going to be what?
Well, I didn't write my graph. Hold on. Okay, the domain.
Because all x's are going to be a possibility because the two rays are going to continue on and on forever and ever and get wider and wider.
Okay.
Domain is negative infinity to infinity.
Is it the x is the y is 1.
Uh-huh. All the way to
Infinity.
correct. And technically, this looks like this kind of bracket because it includes 1. So it's a hard bracket. And then a soft bracket with the infinity.
Okay.
Oh, and then let's see. The transformation on number 7.
Left 2.
Left 2. And the
it's
domain.
quadratic, right?
I'm sorry?
It's quadratic.
Yes. So it's a good old parabola. So what's your range going to be?
-2.
No, because this is your y axis. So where's your first y start?
Oh, 0.
Correct. So it's that hard bracket, 0, and then goes to infinity.
The next one's cubic, right?
Yes. So what's that major turning point? Where is it going to be? What's the transformation?
I'm trying to fill in my graph. The lines are really hard to look at.
Oh my gosh, aren't they?
Okay. It's gonna go left 6, down 2.
Okay, so left 6, down 2. So what's the domain and range on this one?
The domain is it negative infinity to infinity?
It is. Because all x's are a possibility because those rays go on and on forever. How about the range?
-2 to infinity.
On the range, think about it. Where are all y's a possibility?
Negative infinity to infinity.
Yes, sir. Good job. So when you look at the graph, just look at it and kind of like, okay, is there a y that isn't a possibility? That's kind of what you're asking when you get to the range. You're like, could I pick a y that wouldn't be on the graph somewhere? All right.
Okay.
Number 9. What's the transformation?
Right 5 up 2.
Right 5 up 2. And what kind of graph is it?
Quadratic.
Mm-hmm. Good job. All right. What's our domain?
Sorry, I'm trying to write another graph.
No, you're fine. You're fine. Absolutely fine.
Is
Can you think of an X that wouldn't be a possibility?
It's 5.
On the X's, what's going to happen with those rays? Are they going to get wider and wider as they go up?
Yeah.
Okay, so if they get wider and wider, aren't they going to spread out? And like they would, as they get wider, wouldn't every X be a possibility as they get wider?
So is it negative infinity to infinity?
Yes, sir. It is. Perfect. Good job. But your range, I'm sorry? The range?
Yeah, the range is -2 to infinity.
It's +2 to infinity.
I meant +2.
Yeah. So you make that like that kind of hard bracket 2 and then infinity. And I don't think I was doing that before, and I apologize for that. Okay, so now our square root.
It goes left 1, down 1.
Left 1, down 1. So it goes like that. Left. Can you hear my dog whining in the background?
Yeah.
I'm sorry.
You probably can't hear mine, but mine's snoring really loud right now.
Oh, that's normally my dachshund, but he's not. But my greyhound, I may have to go let her out just in just a second. I'm coming, buddy. Sorry about that. Okay, on this one, the domain. Now this is one, okay, when we're going to follow our pencil along the x-axis. Our domain is there. It starts right there because nothing to the left of that starting point is a possibility for an x, is it? Because it's only extending in one direction forever and ever and ever.
It's negative 1 to infinity.
Yes, it's going to be -1 to infinity.
With a hard bracket.
The hard bracket by the -1 and then the curvy one next to infinity. And our y starts there. So it's going to be
the same thing.
-1 to infinity. Good job. Okay, while you think about this one and the transformations, I'm going to go let her out really quick, and then I'll be back. Sorry.
It's fine.
Hey, baby girl. Come here, sweet pea. Come here. Come here. Here, love. Yes?
Let me move further away from X.
Where'd you go? You got to go outside? You need to go out here? I'm trying to figure out what you want, baby girl. Okay. Sometimes I wish you could speak so you could tell me just what you needed. But then I would be afraid if you really did talk. Okay, sorry about that. Are you there?
Yeah.
Okay. What are our transformations for number 11?
Closer to y, left 4, down 3.
Yay! That's it. Closer to y. Left 4, down 3. And this is a quadratic. Left 4, down 3, and skinnier. Okay. So what's our domain?
It's negative infinity to infinity.
It is. Good job. And what's the range?
It is -3.
To infinity. Because if you're thinking about it, your y goes like this. So they start here and go on forever and ever. Does that make sense?
Mm-hmm.
Okay. Okay. What's the transformation on 12?
Closer to y.
Good job.
Right 2, down 3.
Right 2, down 3. And it's a cubic. So right 2, down 3. And it's real skinny. It didn't look real skinny, but oh well. All right, now let's talk about our domain.
For the domain, it would be I can't tell. What is it?
Okay, what x's would be a possibility?
2.
Any x would be, like, because there would be an x. There's an x coordinate here, and then as this goes on forever and ever and ever, this would just get wide. Oh Lord, what happened? Ah. This would get wider and wider.
So that's negative infinity to infinity.
Yep. And what about the y's?
Same thing.
Yes, good job. Pretty much, I think on the cubics, you're going to have that every time. I can't think of another exception on that.
So the next one's an absolute value one.
Yes.
What's the negative sign mean again? Flipped?
It's going to be flipped. Mm-hmm.
Okay, so flipped. Right 2, up 2.
So right 2, up 2. Oops, except I didn't flip it, did I?
No.
All right, now what's our domain and range?
Negative infinity to infinity.
Good job. And then the range?
2 to negative infinity.
Good job. Awesome.
And then this next one is closer to the x-axis.
Good job. Closer to the x-axis.
Up
4. Up 4.
And left 3.
Left 3. So left 3, up 4, and a little bit wider so that it gets pressed down toward the x-axis. Okay, what about our domain?
Negative infinity to infinity.
It is. Good job. And then our range?
4 to infinity.
Good job. Awesome. Okay, the transformation on number 15.
Closer to x.
Closer to x. Good job.
And then up 4.
up 4. Good job. And this is a parabola that's up 4. And it's a little fatter. I don't know if that's much fatter than my other ones, but I was trying. All right, what's our domain?
Negative infinity to infinity.
Yep. And what about our range?
4 to infinity.
Good job.
Need to draw in these graphs.
I'm sorry.
So I just need to draw in these graphs.
Okay.
Okay. So the transformation is down 2.
And one other thing.
Flipped.
Flipped. Good job. And flipped on cubic is weird. Not going to lie. Okay, so we go down 2. And you know how a cubic normally goes like this?
Mm-hmm.
On this one, it goes like this.
Okay.
And it's like, I struggle with it a little bit.
But since it's flipped, doesn't it turn more?
I'm sorry?
It's also flipped. Wait, hold on. Never mind. Sorry, I'm so tired.
Oh, no. Yeah. Trust me. That's why I said it's a little weird on this one. So instead of rising from the left side of the y-axis and crossing over at the origin and going up the right side of the y-axis, it does the exact opposite. It falls from the left side of the y-axis and crosses over and then continues to fall on the right. So it's technically reading a graph from left to right. You would say it's decreasing.
And both the domain and range are negative infinity to infinity.
Good job. That is absolutely correct. Okay. The transformation on number 17.
Closer to x. Or no, closer to y.
Closer to x. Or closer to y, you're right. So it's going to rise more quickly. You're right. Closer to y.
And then up 3.
And then up 3. So it actually just rises more quickly like that. So what's our domain?
0 to infinity.
Good job. And what's our range?
3 to infinity.
Good job. That's it exactly. Let me know when you're ready to move to the next one, because I know that you want to do the graphs or write in the graphs.
I just realized that my computer's about to die. Can I go get my charger?
Absolutely.
I'm having a bit of trouble finding it. Can I have a few more seconds?
Oh, okay, no problem.
Okay, I fixed it.
Okay.
Thanks for waiting.
Oh, not a problem.
We're going to draw the graphs now.
I'm sorry. What'd you say? Say that again. I was trying to answer an email real quick. You've got your graphs done then?
I'm drawing them.
Oh, you're drawing them.
Okay. So the transformation is it goes down 6.
Okay, that's it.
And it's a cubic function, so and then the domain is negative infinity to infinity, and so is the range.
Good job. Awesome. Okay.
This one goes closer to the x.
Yes. Yay. It is because of it being a fraction.
Left 4.
Uh-huh.
And down 2.
Awesome. And this is an absolute value. So the absolute value is going to be a little fatter. That V is going to be a little fatter. So left 4, down 2, and it's going to be a little fatter. So the domain?
In negative infinity to infinity.
Yes. And the range?
Negative 2 to infinity.
Good job.
Down 6.
Yes. That's the exact same one as 21.
Exactly.
Yes. That's nice, isn't it?
I'll just copy it.
And my graph was better on number 19. That's pretty scary.
Okay, so what are these for? rewriting the equation.
Yes.
So I'm sorry, but this is really funny.
Oh, that's okay. No problem. Yes, we're writing the equation on these.
So it's like the last ones, but instead of writing the transformation, we write the equation.
Yes, sir.
Okay.
And I'm trying to see.
Would it be f of x equals x? No, it would be just x squared plus 5.
Yes.
And the domain is negative infinity to infinity, and the range is 5 to infinity.
Yes. It is.
Okay, for the next one, what kind of problem is this? Square root. Okay. So f of x equals square root of x plus 5 minus 2. Is that right?
Good job. Yes. And the domain?
Hold on, I made a quick little mistake when I was drawing.
That's
Okay. The domain is negative infinity to infinity? Or is it negative 5 to infinity?
Yes. And the range?
Negative 2 to infinity?
Yes. Good job.
Okay, this next one is f of x equals absolute value of x minus 2.
Right. Good job.
So the domain is negative infinity to infinity.
Yes.
And the range is negative 2 to infinity.
Good job. I'm trying to see if I don't think any of these. Okay. Okay.
Okay, so the next one is f of x equals x plus 2 minus 3.
Good. And what do I put? With the x plus 2 is in parentheses. Is that going to be squared or cubed or what?
Cubed.
Good job. And the domain?
Oh, it's negative infinity to infinity. So it's the range.
Good job.
Linear one. We haven't seen that in a while.
Yeah.
I almost kind of forgot how to do these.
I know the simple ones those can be the hardest now at this point. So it's going to be x plus 1 because it's not running through the origin, but the slope is still 1. So it's going to be, and it's shifted up 1. Did that help?
Yeah.
And
So
just like the cubic.
The domain is going to be negative infinity to infinity.
And the range. Because all y's are a possibility.
It's just a straight line. And then this next one is an absolute value equation. Units flipped. So it would be f of x equals negative absolute value of x minus 3 plus 2.
Actually, it's going to be x plus 3.
Oh, okay. Oh, yeah, you're right. Yeah.
Plus 2. I don't know if you can read that writing or not, but okay. So what's the domain?
Negative infinity to infinity.
Yes. And how about the range?
To negative infinity.
Yeah. But you technically, oops, I messed this up. Technically, you write it like this.
Oh, okay. Is this just marked the same?
The 28?
Yeah.
Yeah, it's a square root.
All right. This is f of x equals negative.
Good job.
Square root of x minus 3 plus 2.
Good job. All right. So what's our domain?
3 to infinity.
Good job. And the range?
Negative infinity to 2.
Yes. Good job. When they're flipped like that, you really have to kind of think about, where it's gonna venture to. And I'm trying to figure out if this net on number 29, if that looks skinnier or not. I kind of feel like it does. I don't know. What are your thoughts?
I think it looks skinnier.
So we could put a multiplier in front for sure. I'm just trying to think of if you go over 4.
Okay, so I think it's f of x equals 2 x minus 4 squared plus 2.
Yeah, I mean maybe it's skinnier. I can't really tell, but the x minus 4 plus 2 is perfect. I do know that. I
think it's skinnier.
Okay. All right, and then the domain?
Negative infinity to infinity.
And the range?
2 to infinity.
Good job. All right, here's our line again. And this one is rising more quickly. So, goodness.
Is it f of x equals 2x plus 2? Or 1/2 x plus 2?
Yeah, I was trying to see if it's because you're going over, you're going up 2. Yeah, I can't, I'm trying to figure out, what are you? You're going up what? 2?
Yes.
Yeah. Plus 2. I'm venturing to say that that's what it is. I'm having a hard time reading the graph myself. So,
The domain is negative infinity to infinity for both.
yes. All right. How do you feel about these?
There's too many of them.
Do you want to run through about 4 or 5 of them together and then you finish them up?
Sure.
Okay.
So f of x equals x plus 2 squared plus 3.
Good job.
32 f of x equals 1/2 square root of.
Oh, oops. It's not square root.
Or,
I messed that all up. It's absolute value. My bad.
So it's absolute value of
Oh, gosh.
x minus 1 plus 1. I mean, minus 1.
Yes.
Okay, 33 is f of x equals x plus 5 cubed.
Yes.
This next one, f of x equals 1/2 x plus 2.
Closer to the y-axis.
Oh, 2x plus 2.
Yes. Okay.
I think I can do the rest of my own.
Okay.
Thank you so much for helping me.
Oh, no problem. I'm glad. Did it help you? Like you feel clearer about it?
Yeah.
Okay, great. Well, you have a blessed afternoon.
You too.
All right. Bye-bye.
Bye.